So in today's lesson, we're going to look at weight. So again, there's two learning objectives. Recall and use the relationship of weight equals mass times gravity, or gravitational field strength, or W equals mg, and describe the forces acting on falling objects and explain why falling objects reach something called terminal velocity. So the important distinction is between mass and weight. So mass is essentially the amount of matter, that's protons, electrons, neutrons, inside a particular object. And you measure the mass in kilograms. Okay, so the unit is going to be kilograms. So the mass of an object on the moon or Jupiter or Mars is the same as the mass on Earth. Okay, so you always have the same mass. Weight is the force of gravity on an object, and because it's a force, weight is measured in the units of newtons. The weight of an object on the moon is about 1/6 of that on Earth. So you can be weightless in space, but you can't be massless. Okay, and we use something called a Newton meter to determine the weight of this parcel, for example, or an object. Okay, so be careful when you use those terms, mass and weight. They don't mean the same thing in physics. So what is G, this gravitational field strength? So basically it's how strong gravity is. So the gravitational field strength is going to be equal to the gravitational force exerted per kilogram. This is why the units of gravitational field strength are newtons per kilogram. And on Earth, it is around about 10. It's about 9.8, but for IGCSE, and it will be given in the exam anyway, it's about 10 newtons per kilogram. Okay? So in most cases, the field strength is given in the units of newtons per kilogram, but it's also essentially equal to meters per second, the acceleration due to gravity, which is the same. It's about, on Earth, it's about 10 meters per second. So if you fall off a building, you will accelerate at 10 meters per second. And they have the same unit, same symbol, little g, so they're interchangeable. Okay, so how do you calculate weight? Well, weight is essentially the mass of the object in kilograms multiplied by the gravitational acceleration, which we just said is, at least on Earth, 10. So weight is in newtons when it's a mass, it's a force, not a mass. Weight is in newtons because it's a force. Mass is in kilograms, and gravitational acceleration is in meters per second. And that means that on the surface of the Earth, a mass of 1 kilogram has a weight of 10 newtons, okay? A weight force of 10 newtons. So in terms of falling objects, when an object falls through the air or some sort of fluid, say for example water, initially the only significant force is going to be acting on it is going to be gravity. Okay, so if you drop a ball at the start, the only force acting on it is gravity. And that's going to accelerate down at 10 meters per second. Okay, so you throw a ball off a building, it's going to accelerate down at 10 meters per second. However, as the ball begins to get faster and faster, things like air resistance in terms of air or drag, if it's in water, become greater and greater as the object begins to accelerate, move faster. Eventually, the drag force, or the air resistance force, will equal the weight of the object, and we call, and because of this, and force equals mass times acceleration, the object's no longer accelerating, it's now going to be moving at a constant velocity, or constant speed. And this is known as the terminal velocity. So terminal velocity occurs when the drag force, or the air resistance force, equals the weight of the object. Okay, so for 1 kilogram, for example, if the weight of the object is 10 newtons, when the drag force equals 10 newtons as well, then it's going to basically fall at constant speed. So this is a velocity time graph for a falling object. Okay, so the first one, the straight line, is the object in air. When it is in air, okay, it's going to have a terminal velocity. Okay, and then if it's, say, in water, in a liquid, this is the object in a liquid. You can see that the drag forces are stronger, so it doesn't take as long for that terminal velocity to occur. So parachuting is an example of that. So if you have a parachute, you have basically two terminal velocities. Before opening the parachute, it's about 60 meters per second. And then as you open the parachute, you begin to increase the drag force. The terminal velocity is about 5 meters per second, which is lucky in a sense, because if you didn't have a parachute, you'd keep on falling at a constant velocity of 60 meters per second until you hit the ground and go splat. Where if you open up your parachute, then it's going to slow right down and have a terminal velocity of 5 meters per second, which you can survive. Okay, so if you fall to the ground at 60 meters per second, splat. And if you fall at 5 meters per second, you're going to survive that fall. Okay. So this is the velocity time graph for a parachutist. So you have the initial acceleration from time 0, if you fall out the plane, of 10 meters per second. Okay, and this is when you haven't opened your parachute. And then at this point here, the parachute opens, and then we have a second terminal velocity, and then you reach the ground at a very low velocity, so you don't go splat, which is good for you. And also good for the ground because you get to clean it up.